69. Expected value. So we'll mix probability with dollar amounts here. Okay. Expected value is an application of probability that involves the likelihood of gain or loss, likelihood of gaining or losing, right? It is stated as a dollar amount, very important. Okay. Expected value is relevant in business, insurance, and many situations in your daily life. The concept of expected value can be used to determine whether or not, right, here it is, determine whether or not to participate in games of chance. You're like, insurance? That's not a game of chance. Absolutely, insurance is. Yes, it is. Usually the broker wins, right? But anyways, the expected value is only accurate in the long run. Only accurate in the long run. So it wouldn't be accurate if you just play 1 or 2 games, okay? After playing a game many times. You need a large sample size. There it is. Okay. And here's a formula. This formula is very different than the one you have on your formula sheet. I'll show you what it looks like on your formula sheet. But look at the way yours looks like here. It's right here. Expected value, probability of win times gain, minus probability of lose times loss. That's it. It's a very simplified formula. But this is the one that I would suggest you have on your study sheet, because this one helps you way more. I would strongly recommend you have that highlighted, boxed in. I have a note there that this is a dollar amount. Like when you plug in these values, I know this looks scary. A lot of my formulas look scary, but trust me, once you use them, if you use them correctly, you should be fine. But watch this, right? Probability of winning the first prize, right? Then you take the prize, you subtract the cost. So let's say you win $1 million and you paid $10 for the ticket, right? You would go $1 million minus $10 to play that game, right? Because you only really win that much, right? Because you paid to play. Then there's a probability of winning maybe a second prize. Let's say that one is $1,000, right? It'll be $1,000 minus the $10 you paid for the game. Plus, why is there so many dots here, you think? Because there could be a game that has like first prize, second prize, third prize, fourth prize, and so forth, right? We won't go past 3 prizes, so you don't have to worry about that. And then at the end, watch what needs to happen, right? Minus the probability that you will be losing times the cost of playing, right? So there's obviously this is the probability of losing is usually the highest out of all of them, right? So just keep that in mind. That's the pattern I want you to observe. We will calculate that in a bit, but here's what you need to know. You need to be able to answer. This is basically an important concept. Look at the sign. Look at the sign of the expected value. If it's positive, if you plug in all these numbers and you get a positive number, it doesn't matter how big or how small that number is. Gain is expected, right? Good idea to play or invest. If it's exactly equal to 0, we call that a fair game. You will break even in the long run, right? So you choose whether or not you like to play. Maybe you just want to play for the thrill, right? Negative, obviously, loss is expected, bad idea to play, you should not play. That's how we're going to do it in this course. So what is positive? Well, you could get, honestly, you could get 25 cents or $150 or 0.01, right? They're all positive. Those would still be considered a good idea to play in this course. If it's negative, it could be, right, minus, let's say you get 75 cents or negative 1,200 or negative 4.99. It doesn't matter. The main part here is that negative in front. If you end up with a negative, you are expecting to lose in the long run, so you shouldn't be playing that game. Big disclaimer here. The value calculated for expected value is the average amount you are expected to gain or lose per game or bid. This is only true in the long run again. Why do I say that? Because right, I don't want the lawsuit later. It's like, I played this game and I lost money, Mr. Erickson. It's your fault. Right? Even so, even the long run, like what is long run, right? Well, many times, right? You can't just say 10 or 20 even, right? You might lose in between. It will not work only if you play a couple of times. Okay? Let's calculate this thing now. And I'm not starting easy. I'm going right into the harder one here. Come with me to page 70. You know what yesterday I watched, I don't know, it's YouTube, so take it with a grain of salt, but apparently if you're tired, fatigued, if you just look up with your eyes up to the ceiling for like a couple minutes, apparently that engages something in your brain to wake up. So maybe instead of looking down, look up every once in a while. We look at our phones all the time, right? Look up every once in a while because there's something at the bottom of your eyes, blah, blah, blah. I'm not going to go into the details, but I'm going to try it from time to time. A game at the summer fair consists of drawing marbles from a bag. There are 10 red, 30 yellow, 60 white. Okay, so let's count this. What does this add up to? 100 marbles, right? Let's get that out of the way because we're going to need probabilities here. If you draw a red marble, you win 25 bucks. If you draw yellow, you win 7. If you draw a white marble, you get nothing. So this would be sort of first prize, right? Prize 1. This would be prize 2. So in this case, we have 2 ways of winning here. 2 ways of winning. It costs $3 to play the game. I'm going to highlight that because this is going to be very important to include in our calculations. You're with me, right? You're not looking at your phone right now. I know there's probably better expected value examples there, but I'm going to go like this. I'm going to write out my formula. Probability of red, I'm going to go like this. Probability of red times the price for red minus cost. That's exactly what I'm going to do here. There's another way of winning here, which is grabbing a yellow marble. So probability of yellow, I'm going to multiply that by price of yellow minus cost. And here's where the adding ends. There's 2 ways of winning. And then now you need to account for possibly losing. So we're going to go minus probability of losing times cost. That's it. And let's highlight the cost throughout. Cost here, cost there, cost there. Cost is basically going to be in every single chunk, right? This is a chunk, this is a chunk, that's a chunk. Ka-chunk, right? All right, let's do the math here. What's the probability of drawing a red marble? Well, 10 out of 100, right? So we go 10 out of 100. Leave it like that, don't simplify. We would win $25 if that happened. But remember, we paid $3 to play that game. Plus, probability of drawing a yellow, and we look at that, there's 30 yellows out of 100. So you're going to have to be creative as to how you get the probability in here. It won't always be this way, right? Some places will flat out tell you what the probability is as a percentage. Then we go, the prize would be $7, right? If this were to happen, you would win 7. But remember, you paid $3 to play. So you would really just win $4, right? Like in terms of gaining, you would gain $4. Minus, this is the tough one. we're gonna match the denominators we had yet, but what would be the probability of losing in this case? Right? The 10 and the 20, they win you something. So technically, if you get a white one, there'll be 60 out of 100 marbles would not get you anything. So you can see it this way: 100 minus 30 minus 10, or just in this case, just look up at the 60 white. So I'm going to go 100 minus 10 minus 30. Put that in brackets like that. Times, what goes in there? 3, not minus 3. A lot of students put a minus here, and then that minus will meet this minus and turn into a positive. Okay, so this minus is already saying you're going to lose here. Let's clean this up now. I leave 10 over 100. I leave it as is. This is usually easily done in your head, right? So 25 minus 3 is 22. 30 over 100. 7 minus 3 is 4. And here, 100 minus 10 minus 30, that gives you 60 over 100 times 3. And usually at this point, you grab your calculator. You got to be very careful. I do not want you to type that in one shot. That's usually where you make mistakes. So we go like this: 100, 10 divided by 100 here equals times 22. That's 2.2 plus 30 divided by 100 times 4. That's 1.2 minus 60 divided by 100. We know that's 0.6, right? Times 3 is 1.8 minus 1.8. And now you grab your calculator and you go 2.2 plus 1.2. Round to 2 decimals here. I should probably do that because these are dollar amounts. You will get more than 2 decimals at times. So just round to 2 decimals. I will make a note. So I go 2.2 minus plus 1.2 minus 1.8, and I get 1.6. I get 1.6. Here's where you put the dollar sign, right? Unit. Right, the unit is dollars, and it's 2 decimals, and it's positive, right? Like I will put a plus here to indicate, hey, when we type this in, we got a positive. There was no negative in front of it. In other words, it's a positive answer. So you're basically expected to gain $1.60 per game in the long run. You might actually win 25 bucks every once in a while, and then you'll lose a bunch of times. You might win the second prize a bunch of times, but on average, this is what you're expected to gain in the long run. So we would say it's a good idea to play, right? But don't say, some students would say here on the exam, you did everything beautifully. It's like, nah, you shouldn't play. It's only $1.60. Don't play. Right? It's like it's the sign that I want to talk about here. Yes, you should, right? Yes, since the expected value is positive. Okay? Positive. Right? So it doesn't matter if it's 160 or 160 or 360. If it's positive, we go for it. Okay? If you were to play the game 125 times, how much would you expect to win or lose? So technically, you would go 125 games times the $1.60 in this case. And I already calculated that. That's 200 bucks. Total gain expected. That's why this is called expected value. Because so sometimes students ask me, like, where would I use this in real life? Well, you know the flyers that they bring to your house all the time? Does it cost the company money to print those and get them to you? Absolutely. Does every single person end up buying stuff as a result of the flyer in the mailbox? Some yes, some don't, right? So Canadian Tire, they probably do one of these, like, hey, it's going to cost us 20 grand to print these flyers. But we think that, every once in a while we're going to win by customers coming to our store and buying this item that is on sale and possibly other things. So overall, they still are gaining, right? Even though it's going to cost them, right? That's what advertisement is, right? They gamble, but they know they're going to get some money back on their return, on their investment, right? So I'm going to stop here because you're done, right? And I'm done. I'm going to ask you this. For tomorrow, just do one question, either on 71 or 72. I'm going to post both of those, page 71 and page 72. I'm going to post both of those keys and then see if you know how to do it. Okay?